In this video, we're going to solve exponential functions. Now, that does not mean we're going to plug something in for the variable on the right-hand side. It means that we're going to know what the output is over here on the left, and we need to solve for the variable in the exponents here. Let's start by reviewing function notation. So here we need to find f of 7 when f of x equals negative 2x plus 4. Now, there isn't any math to do on the left side here. All we need to do is substitute 7 in for x on the right side and work out the math on the right. All right, so we just figured out that for this function f, with an input of 7, the output is negative 10. Now this problem is different. Here it says solve f of x equals 8 for x when f of x equals 3x minus 7. So here we know the output is 8, but what we don't know is the input. We don't know what number to plug in here in order to get 8 when we work out the math. So what we'll do is put the 8 on the left side because this is the output. And now we need to solve for x. All right, so we just figured out that in order to get an output of 8 in the function called f, we need an input of 5. And notice here, when we substitute 5 for x, we get 3 times 5 is 15, minus 7 equals 8. So when we know what f of x equals, that number goes on the left. All right, here's an example of an application for evaluating exponential functions. The equation below represents the number of bees present in a population in t years, so t is time. Use the equation to estimate the number of bees in the population in 24 years. So the output is the number of bees. So that's the left side here. And notice they tell us that t equals 24. And then notice here we need to round our final answer to the nearest integer, so 0 decimal places. All right, so we just need to substitute 24 for t. So we have f of 24, because 24 is the input, equals 200 times e to the 0.1 times 24 power. All right, now there's no math to do on the left side here, so we just need to work out everything on the right. And e is a number. It's about equal to 2.7, but our scientific calculator will have a button for e, so we'll go ahead and use that. All right, so on the scientific calculator, I ended up needing to put the exponent into parentheses so that it knew to do all that in the exponent part. So I have 200 times e raised to the power of 0.1 times 24, and we get 2,205 rounded to the nearest integer. All right, so we just figured out that in 24 years, we estimate there will be 2,205 bees. All right, let's get to the main event now, where we're actually solving an exponential function. So here we need to solve f of y equal to 2 for y when f of y equals 6.6 times 0.67 raised to the y power. So the variable we're solving for is in the exponents, and we know the output. The output is 2. So after we do the math over here on the right side, we end up with an output of 2. So that replaces the f of y. So it's not our input. We're not plugging it in for y. It just replaces the whole left side. So we have 2 equals 6.6 times 0.67 raised to the power of y. All right, so we're solving for a variable that is in the exponents, and we don't have any convenient bases that we can do something fancy with. So what we'll do is we'll end up rewriting this equation in logarithms. But before we do that, let's go ahead and get this exponential term by itself. So let's divide both sides by 6.6. All right, when I work out 2 divided by 6.6 on a calculator, let's use lots of decimal places because we're not at the answer yet. So I have 0.30303. The 6.6 is canceled, so that leaves us with 0.67 raised to the power of y. All right, we're ready to rewrite this with logarithms. So the 0.67 is the base. So it'll also be the base in our logarithm. So log base 0.67 of the number that is not the exponent, because the log equals the exponent. Most scientific calculators do not have a button that allows you to use a base of 0.67. So we are going to use the change of base rule and use base 10, because scientific calculators do have a log base 10 button. And when we do base 10, we don't write the 10. All right, so y equals, I'm going to switch sides here. So the change of base rule says that log base 10 of 0.30303 divided by log base 10 of 0.67 will tell us what y equals. All right, so over to our scientific calculator. And I get 2.98. So we just figured out that 6.6 times 0.67 raised to the power of 2.98 is about equal to 2. All right, let's try that one more time. We're told that the output is 4. We're trying to solve for m, but it's in the exponents, so we're going to rewrite this with logarithms. But first, let's get the exponential term by itself, so we'll divide by 0.1 on both sides. And 4 divided by 0.1, we just move the decimal place over one spot. We get 40. We're ready to rewrite it with logarithms. So the base is 1.85. That will be the base of our logarithm also, of the number that's not the exponent, because the log equals the exponent. All right, so we can work out the left side on our scientific calculator using the change of base rule. So that's log base 10 of 40 divided by log base 10 of 1.85. Now we'll be subtracting 4 on both sides to get the m by itself, so we might as well do that right now. So I just subtracted 4 on both sides. So on my scientific calculator, we can do all this and it will tell us what m is. All right, we get 1.996. All right, so we just figured out that 0.1 times 1.85 raised to the power of 1.996 plus 4 is about equal to 4. Let's try one last application here. So the exponential function below, f of k, describes the amount of iodine 131 in grams left after k days. So k is time in days. and the output is how many grams of iodine we have. Use it to approximate how long it will take for the amount of iodine 131 to decrease to 1.18 grams. So we want the output to be 1.18. And we're rounding to the nearest integer, so no decimal places. All right, so they told us in the question that the output is 1.18. So that's the left side. So we're not plugging 1.18 in, it's just the whole output. We're trying to figure out what k needs to be so that when we work this math out, we get 1.18. K is in the exponents. So let's get the exponential part by itself. So this is 2 times the number e raised to this power. So let's divide by 2 on both sides. When we do that division problem, we get 0.59. These 2's cancel. Right, and it's time to rewrite this with logarithms. So I have log base e of the number that is not the exponent is equal to the exponent. Now, log base e is the natural log, so we have a special notation for it. It's ln. So I have the natural log, that means log base e, of 0.59 is equal to negative 0.05k. Let's go to our scientific calculator and figure out what the natural log of 0.59 is. And then we're also going to divide that by negative 0.05. So to get k by itself, we'll need to divide by negative 0.05. So in the scientific calculator, we'll find the natural log and also divide by negative 0.05. So the most scientific calculators have a natural log button. All right, and the question asked us to round to the nearest integer. So that would be 11, because that 5 in the tenths place means we need to round that 0 up to a 1. All right, so we just figured out that there will be 1.18 grams of iodine left after about 11 days. All right, I hope these examples about solving exponential functions have been helpful. This is Mr. Ela, signing off.